Boom. Anybody hasn't signed in, don't forget to sign in. Let it clap right there. Okay, here we are. Boom, boom, boom. Week 9. Here's your instructions. We got a weird thing with week 9. Do a week from today. Well, here's the weird part. This is happening again. This happened back at week 5. The Excel assignment must be handed in the spreadsheet for week 9. Let me repeat that. This is one of the rare situations where the spreadsheet has to be handed in as an attachment of the original spreadsheet that is posted. Don't change it. Use that one. You're going to create 2 pivot tables. That assignment says Excel assignment, open the spreadsheet name, DS301 Winter 24 Excel assignment, and follow the instructions. Use the same spreadsheet, and your answer should appear on sheet 2 and 3. So let me show you. Where is it? Right here is the assignment. You're going to hit this little plus sign down here. If none of you have ever, you don't even have to hit that plus sign. When you follow these directions on how to create a pivot table, you're going to say and I'm going to go over this on Thursday, by the way, in detail. But there's going to be a question as you start to create your pivot table that says, do you want it to be on a new worksheet? And you're going to say yes. And all of a sudden, a second worksheet, let me show you, just like that, there's number 2, will show up. And the second problem will be on worksheet number 3, right there. And there'll be a third week worksheet showing up. And then you're going to save it. Maybe put your name up here when you go to save it in the title somewhere, just your first name or last name or something, initials, so just to make it unique. And then you email it to me as an attachment, not through Canvas. If you can please avoid Canvas, that sometimes things do not work out when they're going through Canvas. Just directly email it to me as an attachment. Again, this is one of the rare times where you're emailing me a spreadsheet instead of handwriting the answers, because it's a pivot table. Now here's another thing that's really weird about this pivot table that's due a week from today. You either have to do it right or you have to do it over. You can't get a grade. You either get 100% on this part of the homework, the Excel, or you don't, or you get a 0. The pivot table has to be done right, or you get it back. Or it's sent back to you saying you haven't done this right, re-hand it in. So it may even be in your best interest to hand in the pivot table early, so I get a chance to review it before the due date, and send it back to you and say redo it, because you can't get a grade on it all unless you do it right. That's the weird part about this week's homework also. Just the pivot table part of it. The written's just like any other written, but the pivot table Excel part has to be done right. All right, there's that. But again, I'm going in detail. I want to get rid of this sheet. Yeah, I want to get rid of this sheet. We're back to sheet 1. Okay, I'll go over that in detail on Thursday. Let's go to the written assignment. Here's the written one. You've got 1, 2, that's it? Oh, come on.
Yeah.
Yep, that's it.
Just 2?
Yeah.
Yeah.
Oh.
That is.
And what you have to do with these is to show me detailed work that you're proving the 2 events are either independent or not independent of each other. And that's what today's all about, independent events. And here is one of the most common ways to prove whether 2 events are independent of each other or not, called the multiplication rule for independent events. And that rule says the intersection of these 2 events, if it equals the probability of one event times the probability of the other event, and it equals that intersection of these 2 events, you just prove they're independent. If the probability of one event times the probability of the other event does not equal the intersection of the 2 events, you just prove they're not independent. And over here are 2 other ways to prove whether they're independent or not independent that I'll go over also. And then we're also going to learn the if function for Excel, which is one of the most important and the most highly used Excel functions of all. If it allows you to do what's closest you can get to programming Excel spreadsheets. And then we're going to review conditional probabilities and the multiplication rule. The reason I want to review the multiplication rule is because it's not the same as the multiplication rule for independent events, and I don't want you to get them mixed up. Let me repeat that. We've already learned the multiplication rule But we haven't learned the multiplication rule for independent events, and I don't want you to get them mixed up. All right? This multiplication rule for independent events is like the most common way to determine if two events are independent or not. All right, so where do we start here? Let's start with reviewing this. This is from, remember that chapter 4 PowerPoint we looked at several different weeks. This should look familiar. I've also put it on the board. I want to refresh your memory. There's Markley Oil. We got this, we're all sitting in a meeting right now. We're talking about this extra cash we have on hand. We said, hey, we aren't going to need this cash for the next 3 months. We're going to, we have 2 investment opportunities, and one investment opportunity has 4 possible outcomes, and the other one has 2 possible outcomes, right? On the left are the 4 possible outcomes for Markley Oil. Either we, at the end of 3 months, that we give them our cash, one of these 4 things are going to happen. We're either going to make $10,000, make $5,000, break even, or lose $20,000. So it's a pretty big risk. The other investment that we're going to give cash to for 3 months has 2 possible outcomes. Either make $8,000 or lose $2,000. So we put together these outcomes because the money's going to be at these 2 investments for the same 3-month period. And they're both going to give us results at the same time. So together there's 8 possible outcomes. 10 and 8, 10 and -2, 5 and 8, 5 and -2, and so on and so on. There's the 8 outcomes. So then, if you recall, we had a meeting and we debated what the probability of each of these 8 outcomes would be. Hypothetically, we did this. Does this sound familiar? It's all kind of review, right? And we came up with these percentages. We thought, hey, this 20% chance of that outcome, 8% chance, 16, 26, 10, 12, 2, and 6. There they go. And they add up to 100%. One of these outcomes have to take place because we're handing over our extra cash for 3 months on these 2 investments. Does anybody remember what kind of, we went ahead and put these probabilities to each of these events. There were 3 different methods I taught you, and every time I bring this up, I keep asking you, what was that method we used to apply these percentages? No? What was over here? I heard it. Subjective. Subjective. Is that what you say?
Classical and relative?
No, not classical. It's a subjective one.
I know, but you asked for the methods.
I'm sorry?
You asked for the methods, so I was just getting.
Well, I just wanted the method we used for this one. So subjective means we pulled it out of thin air. Kinda. I mean, we debated it, but it's just, you know, there's no real anything proving that these are the percentages. But we used our best judgment based on talking about it out loud. And there they are. So now, since we have, and believe me, if this is a problem on the quiz, you're given these percentages if they're subjective. If they're classical, you would just say, okay, I'm gonna take 100% and divide by 8 and apply it to each one because they all get the exact same one. That would be the classical method, and I wouldn't have to give them to you, but if it's subjective, I'm giving you those percentages. Now, we gotta review conditional probability. Conditional probability says, hey, if hypothetically one of the events took place, you can only look at that event, you then calculate what's the probability of the other event taking place. So I put 3 of them up here. One of them, I'm jumping to it right now. Oh, whoa, I'm sorry. I want to make sure we have the percentages here. I went ahead and took 4 variables for 4 different possible events here. You ready? I made M be Markley makes a profit. Look at the ones Markley makes a profit. How many out of these 8 do you see where Markley, the first investment, is making a profit?
4.
4 of them. And we did this already a couple weeks ago, and the 4 of them were right there, and it added up to 0.70. There's that one. This next event, I'm going to do the C because we've done this one already in the past. Collins makes a profit. That would be the right-hand one. And how many do you see out of 8 that Collins is making a profit? 4 it is. And there it is. Those 4 right there. This is 0.48. But we haven't done these other 2. So real quick, let's do them. The probability, M2 is going to represent that Markley Oil doesn't make a profit, does not make a profit. Look at the first column. How many of them does it have the first investment not making a profit?
4.
4 of them because 0 is not making a profit. That's a break even. You've got to count the zeros also, so that's why there's 4 of them. List them for me. I see 0.10. Here we go. 0.10 plus. Come on, you guys. help me out. 12. 0.12 plus.
0.02.
02. 0.02 plus.
06.
06. There it is. What does this equal? 10, 22, 23, 24, 0.30. This one's 30%. This one we haven't done. Collins Mining doesn't make a profit. Doesn't. How many out of 8? She says 4. I'm looking up there, all the negative 2s. So we gotta add these up. This is gonna be 0.08, help me out, plus 0.26 plus 0.12 plus 0.06. Thank you. 8, let's see, 26 and 8, what is that? 34, 44, 34, 44, 45, 46, 46, 52, is that right? Anybody else get 52? Should I do it again? 6 and 6 is 12, so that'd be 20, 32, 42, 44, 44 and 8 would be 52. I get it? Still 52, right? Okay, we now have the probability in each of these 4 events. All right, we're there so far. Now we got to look at these conditional probabilities, taking this into consideration. Here we go. I'm gonna forget this. Let me put these 8 back up here again, in case in the back you can't see the board. You can see those. There they are again. The first one says, if Markley makes a profit, if Markley Oil makes a profit, or assume, or let's assume Markley Oil makes a profit. There's the given. Given Markley Oil makes a profit. There's a good word to start with. That's the condition. That means your denominator could only be the percentages used where Markley Oil's making a profit. And which is how many? You said 4 of them, right? So the denominator has 4 numbers in it. What are, well, we already know. If Markley Oil makes a profit, but I want to list all the 4 numbers. 0.20 plus, what are they? 0.08
0.16
plus 0.16 plus 0.26. There's our denominator. Now here's the deal with conditional probabilities. The rest of the question that asks the probability of something has to come out of the denominator. You can't look at the other 4. That's what conditional probability is all about. The numerator has to come out of the denominator. The denominator represents the condition, and the numerator has to come out of the denominator. So we can only look at these 4, the 20, the 8, the 16, the 26, to answer this question. If Markley Oil makes a profit, then what's the probability Collins Mining also makes a profit? We can only look at these 4, these top 4, and the 2, only 2 of them, of these top 4, have Collins Mining making a profit. So only the 0.16 and the 0.20 can go on top. 0.20 plus 0.16, this ends up equaling 0.36 over 0.70. Is that right? Or 0.30? Oh, 0.70. Did I do something wrong? What did I do?
I thought there was more
Do
than
they both
one
have to
that
make
makes a
profit or just one of them?
It's not just 2 of them.
Okay, hang on, let me go back. If Markley makes a profit, here's the top 4.
Oh, yeah, they
You
do.
can only look at those top 4. And then it says, what's the probability Collins Mining makes a profit, which is out of these 4 are only the first one and the third one. You can only look at these 4 because that's the condition. All right. Now we found the conditional probability, 0.36 over 70, which by the way, that was our example of conditional probability, which is right here. Let me get to it. Here it is. It says, given Markley Oil is profitable, what's the probability that Collins Mining is profitable? They're 0.36 over 0.70, which is 0.5143. 0.5143. Let's do a second one now. This one is not, we've never done the second one that we're about to do. It's not on the PowerPoint. But it says, let's assume, or if Markley Oil makes a profit. There's our denominator, nothing changed. I don't even need to write all those numbers out again. It's 0.70, we got it right there. Markley Oil makes a profit. Let's assume Markley Oil makes a profit. What's the probability that Collins doesn't make a profit?
0.34.
Well, hang on a minute. Hang on. What numbers out of these 4 are being used at the top? Which ones out of those 4 are being used for the numerator?
0.8,
0.08 and 0.26. Very good. 0.08 plus 0.26 are the only 2 out of those 4 where Collins Mining's doesn't make a profit. So in this case, we have, what does that equal, 34?
Yeah.
0.34 over 0.70 equals, this we don't have, we gotta get our calculator out. Calculators, help me out. I don't need to do this. Point what?
0.486.
No, 0 point what?
486.
486, what's the next digit? What's the next digit? Back up. Backup plans, anybody? Seriously, I could have swore you had.
I got it.
486.
0.
Zero?
Zero.
What's the
Zero.
next digit after the zero?
4857. No, it's
04?
Four.
04?
no. 4
It
8
was rounded, the
5
source was rounded.
7.
Oh.
So it's 4 8.
Why, who's rounding 3 digits?
No, it's not me, it's 0.
Okay, hang on. Here we go. 0.34 divided by 0.70 is
Zero.
4 8
8
5 7.
7 what?
1.
Okay.
1.
Alright. What's the number after the 1?
4.
You see, I asked about the next number, so I know what number to put next. Because I have to know what the next number is after that. Since it was a 4, then I know not to put a 2 and a 1. There we go. That's our second conditional probability. The reason these are important is you can use these conditional probabilities. Matter of fact, let me put the letters here for this one. This represents, what was this? Collins Mining makes a profit, which was what letter up there, which is an M, right? The M is what's on bottom, right? And then what was on top would be Collins Mining makes a profit. So that would be the C. There's the conditional probability C over M. Collins Mining makes a profit after we assume Markley Oil makes a profit. Now let's do this conditional probability using those variables I listed, those 4 variables. If Markley Oil makes a profit, that's an M again. What's the top one though? Collins doesn't make a profit, which would be C2. Very good. Here's another one. If Collins doesn't make a profit,
C.
that's our denominator. If Collins doesn't make a profit, so here we go, our denominator is going to represent how many numbers has Collins Mining not making a profit? How many of these? Out of 8, can't hear you.
4.
4 of them, there we go. 0.08, 0.26, 0.12, so here we go. 0.08 plus 0.16,
2 6.
thank you, plus 0.26 plus 0.12
2.
plus point what?
0 6.
0.06. There's our denominator. 8 and 12 is 20, that's 46. 46 and 6 is 0.52, is that right?
Yeah, I already did it.
We did this?
Yeah.
Yeah. Okay, now the numerator can only come out of the denominator. We're assuming that Collins Mining doesn't make a profit. What's the probability Markley Oil doesn't make a profit? So you can only look at these 4. So that'd be this one. Is this count in the on the numerator?
No.
Okay, what about this one? Does that count in the numerator?
No.
What about this one?
Yes.
0.12, and what about that one?
Yes.
0.06. 0.12, 0.12, and 0.06, which equals 0.18, correct? 0.18 over 0.52. Okay.
Yes.
Here we go. Now take me out. Here we go. Point what?
3, 4,
3, 4, 6, 1, 5.
3, 4, 6, 1. What's the digit after the 5?
3.
5. Very good. There it is. This conditional probability is the denominator was Collins Mining doesn't make a profit, so C2. The numerator was and Markley Oil doesn't make a profit, so that's M2. We just did the conditional probability. Let me put a P there. Let me put a P there. Let me put a P there. The conditional probability of M2 over C2. Conditional probability, let me go back to, hang on, let me go right here. The conditional probability, whoops. Is the probability of the given under the probability of what's being asked the probability of, which is considered the intersection. Okay, now, are we ready? We got everything ready for independent events? Let me make sure. Oh, the multiplication rule, let's review it real quick. There's the multiplication rule. The multiplication rule says the intersection of 2 events is equal to the probability of the second event times the conditional probability of the second event being the denominator and the first event being the numerator. I'm sorry? So, you wanna see an example of that?
Yes.
Let's do that. Do we have intersections? We don't necessarily have intersections right now. Oh, here's an example right here. What am I saying? You ready? Here is the intersection of two events. Markley Oil and Collins Mining. What's the probability of those two intersections? So Markley Oil is the M, 0.70. Collins Mining profitable is the C, 0.48. Well, let's look at it this way. Here we go. You ready? M and C. Look at all 8 of these. Count how many that at the same time, M, the first column's making money, and C, the second column's making money. That's the intersection, when they're both doing it at the same time.
Two.
You only see 2 of them?
3. No,
Oh.
no, I'm sorry.
The first one and the third one. You agree?
Yes.
So, the intersection of, what is this? M, upside down U, C. The intersection of these two events is right here, 20 plus 16. So I'm gonna put 0.20 plus 0.16, which equals 0.36. There's that intersection. That's right there. Now, let's look at what the probability, let's go back to the multiplication rule. It says that once you found that intersection, if that's the route you're going, and let's say you know the probability of one of the events, the second event, which by the way would be the C, what's the probability of C? Probability that Collins Mining makes, we already did this, it would be the 8, all of these, so that'd be 20 plus 16 plus 10 plus 2, probability Collins Mining makes money, which we did right here, 0.48. So it says, take the probability of the second event, multiply it times the probability of the conditional probability of AB. Do we have an AB? That would be where Collins Mining makes a profit. We don't have it, do we? We don't have it, so here we go. Here's the conditional probability, where is it? AB, which would be MC. So this says, given Collins Mining makes a profit, that's our denominator, here we go. Collins Mining makes a profit, we got it right there, 0.48. It happens to be 0.20 plus 0.16. Here we go, 0.20 plus 0.16. Where's the other 8s? 0.10 plus 0.02. So the condition says, given Collins Mining makes a profit, we've got the 4 that Collins Mining makes a profit, that equals 20, 36, 46, 47, 48. 0.48 is our denominator. Now we can only look at those 4. What's the probability Markley Oil makes a profit too? After Collins Mining makes a profit, we can only look at these 4. What's the probability Markley Oil makes a profit? So we'll start with the 20. Does this one count?
Yes.
Yes.
So 0.20 is on top. Next one, 0.16, does that one count?
Yes.
0.16 is on top. Next one, 0.10, is that one count?
No.
And the next one's 0.02, does that one count?
No.
No, they're both loss and break even, so they are not Markley. So the numerator only has 0.36. Now here's the deal, you ready? If we did this right, you take, let's look at this, you take 0.48 times whatever this equals, it should equal 0.36 if we did this completely right. Or if we take 0.36 divided by 0.38, use algebra, 0.36 divided by 0.48, 0.48, excuse me, we should get the same answer here, which by the way, 0.36 divided by 0.48 are the 2 numbers. So these are definitely going to equal. Go ahead. Hang on, I can't hear you. Can someone hear? I got the fan on, so I can barely hear you, I'm sorry.
Yeah, is there a reason you didn't add the other 2 the way it's marked?
Add the other 2 with Markley.
What are we talking about? Right here? Are you talking about this?
Get out of your voice, man.
Hang on, let me turn off this fan. I cannot hear you sizing it. Marion, go ahead, do it again. Sorry, go ahead.
I mean, it's a question personally. Is there a reason why it's not 0.70 instead of
Oh.
0.36?
Okay, I see what he's asking.
Yeah.
Okay, you're saying marketing oil, this being 0.36 right here?
Yeah.
This all by itself is looking at every one where it's positive, all four of these added together. But this one is a conditional probability, so it can only look at these four and which ones are profitable out of these four. So it can only look at this one, which it is profitable, this one, which it is profitable, this one, those break even, and this one's losing 20, so that's why it can't be in the numerator like that one is. So this one's all of them, out of all 8 that marketing makes money, but this conditional probability is only the ones marketing's making money that Collins made money first. So Collins had to make the money first, we could only look at those. So what is 0.36 divided by 0.48? Someone's got it. What is it? 0.75 on the nose? 0.75. Notice this conditional probability, 0.75, is the same as taking this divided by that, which is the intersection divided by. Or if you take the probability of 0.48 times 0.75, you're gonna get 0.36. That's the multiplication rule. Now, this is all led up to us learning about the multiplication rule for independent events. We're trying to find out if 2 events are independent of each other, so let me get to that. Here are 2 different ways to determine if 2 events are independent of each other, which are right here on the board. It says if you take the conditional probability given B, then A, and it equals the probability of A all by itself, you just prove they're independent. Let's do this one. Now we flip them. If you take the probability given A, then B, and it equals the probability of B, they're independent events. A lot of students find these 2 harder than this. Just find the intersection of the 2 events, see if the probability of one event times the probability of the other event equals that intersection, and if it does, they're independent of each other. In this case, you didn't have to do a conditional probability calculation. You only had to have the probability of one event, probability of another event, and find the probability of the intersection. So I'm gonna now, I want you to help me pick 2 events here. I know it's warm in here, isn't it? 2 events in here. Can I turn the fan back on? All right. I want to pick 2 events. We got 4 of them here. I want to pick 2 at random, and let's figure out if they're independent of each other. I'm going to use the. I don't know which one I'm going to use. Wait. Let me first give you an example, and then we'll do one of our own. So the example is going to be: is Collins Mining? Let me put it up right here. Is Collins Mining being profitable, which is your M, and I'm sorry, is your C, and Markley Oil being profitable, which is your M? Are those 2 independent of each other? Here's what we need. Here's the probability Markley Oil makes profit, 7.70. Follow this rule right here. We're going to make Markley Oil making a profit our A, our first one, 0.70. So here we go. 0.70 times the other event that Collins Mining makes a profit. That's our C, 0.48. Now, if those 2 being multiplied happen to equal the intersection, and there's the intersection right here, Markley Oil and Collins Mining both making a profit at the same time, which we said was just the first and third, 0.36. If 0.70 equals and times 0.48 happens to equal 0.36, you just show you have independent events. So here's what I'm going to do. I'm going to take 0.70 times 0.48. I don't have to. You guys just did it. And what'd you get?
0.336.
And there it is right there. 0.336. Is that what you said?
Yeah.
Why does it say 0.34? Oh, okay, it's rounded. 0.336. What's the next digit?
That's it.
That's it? Equals 0.336. Then I'd say 0.336 does not equal 0.36. Therefore, they are not, very good, not independent. Therefore, they are not independent. Everybody see that? Okay. Right there it says 0.70 times 0.48 is 0.336, says 34, we rounded. And the intersection is 0.36. They're not equal to each other. Therefore, these two events are not independent of each other. Now, I want to do two different events. And we're going to do it ourselves without a visual here to figure out if they're independent of each other. This will be just like a test question. Here we go. Hey, you guys help me. There's 4 of them here. Just don't pick M and C all by themselves. You go M and M2, C and C2, C and M2. Pick 2 different ones of those, Markley and Collins. How about M2 and C, or C2 and M, or C2 and M2? Which would you like?
M2 and C2.
Which one?
M2 and C2.
M2, C2? M2, C2. So here's what we're going to do. All right, I'm going to clear these off. We're way over here. Yeah, I want to clear some space here. And we're going to go right here. Okay, M2, C2. We're going to determine if they are independent of each other. The good news is we already have the probabilities of the 2 events right here. Is M2 and C2 independent? IND, I'm abbreviating. Are they independent? How about are? There we go. Are they independent of each other? It says, the rule says, let me go back, and we can take the 2 events and multiply them, and if it equals the intersection, they're independent. Here's the 2 events, M2. M2's right there, 30%. Times C2. Collins Mining doesn't make a profit, 52%. Let me review. We got M2, Markley Oil doesn't make a profit by finding the events that show Markley Oil not making a profit. 0, 0, negative 20, negative 20. We added these 4 and we got 0.30. Collins Mining not making a profit. We looked at the second column and we picked the ones where Collins Mining's not making a profit, which is the 0.08, the 0.26, the 0.12, and the 0.06, which equals 0.52. Now we're going to multiply them. 0.30 times 0.52 is
156.
156.
No, that's it.
0?
Zero.
All right, 0.1560. There it is. Now, here's what we don't have. We don't know what the intersection is. So let me write this out. We got to find the intersection, the probability of M2 upside down U, C2, the intersection of the 2. Here's the deal. You look at all 8 of those and tell me how many have both Markley Oil and Collins Mining not making a profit. Both of them not making a profit. I see how many? I see 1, I see 2. I see 2, you see 2?
Yes.
Here we go. The intersection is 0.12, 0.06, you agree? Sorry, not 0.0, nothing. 0.12 plus 0.06, which equals 0.18. Here it is. Since 0.18 does not equal 0.1560, these two events are not independent. And there's my work to prove it. All right, so I want to show you this. Yeah, we're doing a time here. This is posted. Whoops. This is posted where I go into detail. To prove 2 events aren't independent. So I went first with our. Let's see, what did I go with? The question says, are events M and C independent? Which we did already before this one. And there's the detail, so you can see I did it both ways. Here is finding the intersection and seeing if it equals the 2 events multiplied by each other right there. And I got 0.36 does not equal 0.336. But right above it is me using one of these 2 ways. Using one of these 2 to also prove whether the 2 events are independent or not. So you see an example of the other way. It says no, because the probability of the conditional C over M does not equal the probability of C, which is 0.5143 does not equal 0.48. So that also proves they're not independent. So I showed you 2 different ways there. I want you to scroll down though, So I went ahead down here and showed you two different ways with M2 and C2, which is what you just happened to have picked to do here, M2 and C2. Let's confirm the numbers from this that I have posted here. I did it both ways. Hang on a minute. Let me scroll down to both ways here. Here it is. It says no, because the intersection of M2 and C2 does not equal the probability of M2 times C2. And the numbers I got are 0.18, there's 0.18, and the other number I got is 0.5156, and it says these two are not equal to each other, right there at the bottom. Also, right above it, I went ahead and proved they're not independent, again, using one of these also, in case you find this easier. Not many people do. If you want to use a conditional probability though. And it also proves they're not independent because it went with 0.60 does not equal 0.52, using one of those two ways. So here are some examples using two different ways, two different examples of finding the independent probability.
How do you use that?
How do we use what? The one on the far left?
What, is that the conditional? Or?
That's using the conditional probability to determine if two events are independent of each other. Let's do it real quick. Hang on a minute. Let me find one that we already have the conditional probability right here. Here's the conditional probability, C over M, which comes out to be, here it is, there's that. What do we compare this to figure out if they're independent events? Do we compare it to the C or the probability M? Look at the up there. Look at where the letters are.
C.
Do you compare it to the C or the M?
The C.
That's right. Whatever the letter on the left of the conditional probability is what you got to compare it to. So I got to determine is 0.5143 equal to or not equal to the probability of C. Let's look at what the probability of C is. It's the first one, the third one, the fifth one, the seventh one, which we calculated right here to be 0.48. 0.48. So therefore, let's look at this. 0.5143 does not equal 0.48. It cannot be independent events. Using the conditional probability is another way to prove it, and you can use either one on the quiz. What? You mean you have to prove independent events on your homework and the quiz, the next quiz, a week and a half from today? Yes, most likely so. 99.9% chance it'll be on the quiz. That's probably the harder question on the quiz, actually, is proving two events are independent of each other.
So what's this method called? As well as the
This one's called using the multiplication rule for independent events. That's this one I did, and this one's using conditional probability to determine independent events.
How did you get the 0.48?
The 0.48, we already had calculated, because we had to compare it to the probability of C, because C's on the top here, this conditional. So the probability of Collins Money making a profit is wherever the 8s are, and I added those already right here and got 0.48. And so that's what I was comparing it to, the 0.48, the 5143, and they're not equal. They're close, but they're not equal. Okay, we have only a little bit of time now. We got a lot of time. We got time. We got to do an if statement though. This if is a big deal. This if is such a big deal that you should consider this to be on your quiz also. That's how big of a deal if conditional, if statements are in Excel. Let me see if I make this big. Too big? Okay, here's the first example of an if statement. I want to tell you, one of the ways if statements are used, a lot of you are going to have to take, you're all business majors, so you're going to have to take operations management, and some of you are going to take a class called management science. Operations, you already had operations?
I'm taking it right now.
All right, is it hard?
I don't like it.
She doesn't like it, but she likes stats, so you know it's got to be hard. But I don't know if you've gotten into writing simulations yet in operations. Have you done simulations yet?
I don't think so, man.
In management science, you definitely will do simulations, and I'm not sure management science is required. It may be an elective. I want to tell you, it's one of the best classes. So if you have a chance to take management science as an elective, and you're a numbers-oriented person, you've got to take it. It's a great class. I would say I use the things you learn in management science, I use in the real business world more than any other class. So in that case, there's simulation. And if statements are used all over a simulation. When are simulations used? When you're at a company and you've got to spend a couple $1 million to possibly do an expansion to make a new product, for example, You're gonna sit in a bunch of meetings and discuss it and simulate what would happen if you truly spent this couple of $1 million to expand your business and get into this new product. And you're gonna simulate it by, hey, someone from production came and they went ahead and did a test run. Someone from materials who are buying all the materials for this thing. Let's say we're a golf manufacturer. We already make golf clubs. We already make golf balls, but we don't make golf bags yet. And we want to get into golf bags. We got somebody who went and priced out all the materials that are needed and what the prices will be per golf bag. Bought some of the materials, even made a golf bag to see how much of the materials are going to be used, how much time it takes to make one. All of this is done before the expansion's done. Everything's analyzed. And then it's simulated. Okay, we've come down to realizing our golf bag will cost us between $42 and $48 to make. We also think to be able to get a market share that we can sell this golf bag for about $99 wholesale, leaving our retailer at about $149, making their profit. See where I'm going with this? This is all talked about in meetings before. Everything's planned out in advance. What will our initial sales be? The head of marketing's there is going to tell us what's our possible initial sales. Well, marketing doesn't know that for sure. They don't have a ball, so they estimate it. They say, we think we can sell between 5,000 and 10,000 units in the first year. We believe that for sure we're going to sell 5,000, and if things go like they should go and we have that price point, we think we could get to 10,000, 5,000 to 10,000 in that first year, and so on. Everything is simulated. So what we do is you use if statements to simulate every possibility. Our cost is low on the golf bag. One simulation will simulate that our production cost was lower than we thought it would be. Our sales were higher than we thought it would be. Our overhead is right what it should be. These kind of things are all simulated, and then at the end is, did we make a profit that first year or not? And then, if there's a machine we had to buy involved, we gotta estimate the second year's sales, the second year's cost, the second year's overhead. Matter of fact, we think the life expectancy of this machine is 7 years, so we're gonna forecast 7 years sales, 7 years cost, and we're gonna simulate every combination. Line 2 is simulating high production costs, higher than average overhead, lower than average sales than what we expected. Every possibility of all the things that are unknown, but we have a range, we use if statements to change. Once you write that first line with all these if statements, if this cost is this low, if the production overhead is this high, if sales are this point, all of these things, and then you copy and paste it for the next 999 rows below it. That's how simulations are made. All the work's in that first line, and then it's copy paste. And so it simulates using randomness. Let me make sure we're gonna head towards randomness. This is gonna make more sense. But it uses randomness to simulate every possible outcome. And then you come back to the meeting after the simulation is done, and all of us, head of marketing, head of production, head of materials, me, I was always the finance person. I'm there trying to be the person who stays grounded and says, now look, we're about to spend $2 million. Is this for sure the cost of materials? Is this for sure our production cost? You go to the far end of the simulation, the far right-hand side, and it determines if over the 7 years, how did it end up? Did you end up making money or losing money? And then at the meeting, you count how many out of the 1,000 simulations you lost money. And the rule of thumb used to be, if you're losing money on this simulation, 10% of those 1,000 simulations, you're taking too much risk. Yes, that's a 90% chance you're gonna make money, but that's still too much risk. Because look at the most you can lose. That's another thing you get from the simulation. Here's the most the simulation says you can lose. Oh my God, we could lose $10.5 million over the 7 years. That's the risk we're taking. And do we want to take this risk? And so some companies are real conservative and they say, the simulation has to show that there's only a 5% chance we can lose money, then we'll go forward. It all depends how conservative or how much of a risk taker the company is and the management team that's in place. That's how business is done. Big decisions that cost millions of dollars are first debated and simulated to determine if we're making the right decision instead of just winging it. Small companies who only maybe have a person, the founder, leading it, and maybe they're only doing 20, 30 million in sales, that person's probably making decisions on their own and they've never learned how to do simulation. And so they make mistakes and they lose millions of dollars because of it. And some companies, it puts them out of business. And that's why it's so tough to keep a company in business, especially at the beginning of the lifespan, of the life cycle of that company. And using the tools you learn in management science, and believe it or not, statistics too, it helps you make the good decisions so you don't lose the company and don't cause it to go into bankruptcy. So here's an example of how if is written in an Excel problem. This one is saying, I want to know if C12, what's in C12 here? 112. I want to know if C12 is greater than 100. So in an if statement, the beginning is the question you're asking the computer. And the question either has to be true or false. So whatever you're asking Excel, it has to be a question that can be answered as true or false, comma. The first part is if it's true. Tell it what to do. If it's true, do this. In this case, it's quotation marks and wants you to put the word greater there, comma. If it's false, you're telling Excel what to do. And in this case, we're telling Excel, hey, if that first thing is false, if C12 is not greater than 100, then put the word not greater in this cell. That's how you use an if statement. Again, the beginning is a question you're asking Excel that can be answered true or false, comma, here's what you're telling Excel to do if it's true, comma, here's what you're telling Excel to do if it's false. Now what's great about it is that second comma, what you're telling it to do if it's false, you can literally insert another if statement, because if that one's false, sometimes you want to ask it a different question. And then you have the true and false. And if that one's false, you can ask a third question, true and false. And if that one's false, you can ask a fourth question. I've seen where there's 10 questions in one line of code on Excel with if statement after if statement after if statement. That's how, this is the closest you can get to truly coding a spreadsheet in Excel, is using if statements. That's how common they are. So you got to get a handle on these. Here's another one. This one says, look, if average of all that data between C7 and C31 is less than 90, that could be true or false. Is the average less than 90 or not less than 90? If it is, if that's true, put the word less than there. And if it's false, put the words greater than. I'm telling Excel to put, there's two options there. Sure enough, it found the average from C7 to C31, and it was less than 90, so it put the word less than there. You getting this? Now it's going to get a little more tricky. Can you believe it? I just had it felt like my phone was vibrating in my pocket, like it was ringing, but there's no phone there. What is that called? Like a false, some kind of false, like there was, I don't know, that was weird. Anyway, you ready? Tell me anybody know what this is doing? What is this doing? What's the question being asked? Put it in words. What's in C7? 33. So it's saying, is the number 33 what?
Greater than 25.
Greater than 25. There's the question. Is it? It is.
Yeah.
So it went past the first comma and said, oh, this is true. If it's true, look at what I'm asking it to do. Count if C7 to C31 AB. It says, hey, if C7 is greater than 25, I want you to go and look at all the data and count how many ABs there are. And sure enough, let me show you the rest of the data. Hang on, I gotta scroll down. Look at the bottom. There were 2 ABs in there. So I literally said, okay, if that's true, I want you to count the ABs, and it counted 2 ABs. Count if C7 through C1 is an AB. If this isn't true, if C7 is not greater than 25, if that ends up being false, put the word no there. But it was true, and it went and counted ABs. But look at how many different things you can put, telling it what to do if it is true, telling it what to do if it's not true. You can be so creative here with all the other things you've learned can be inserted within these parentheses. Here we go. This one says, if C29 is greater than 50, let's find C29. Oh, we gotta go down here. C29, there it is. Is it greater than 50? No. But if it were, it says put the words greater than 50 there. But it wasn't greater than 50, so after the next comma, look at what I did. I put another if statement. Let me scroll over a little. I put another if statement. So let's review. If C29 is greater than 50, C29 is 34, it's not greater than 50. But if it were, it would have said put greater than 50 there. But it's not, so it went to the false. False. Now I'm asking a new if statement. If C29 is less than 30. Is C29 less than 30? No, it's not, it's 34. It's not greater than 50, and it's not greater than 30. So then, if it's true, put less than 30, but it's not, it's 34, it's not less than 30. So I can make the assumption, now I said, okay, it's not greater than 50, it's not less than 30, I can make the assumption, if that's false, put the words between 30 and 50, and sure enough, it is between 30 and 50. You see the different ways you can use if statements. I got, what do I have, 2 more here? Here we go. Oh no, here's the question. Write an if statement that will determine if the median is greater than 70 or not. Then let the results say, hang on, what are we gonna let the results say? Oh. The result should state if it is or isn't. So here we go. Write your if statement. You're gonna write an if statement. I'm gonna show you the answer in just a minute. Right now, in your mind or on paper, write the if statement, and someone raise their hand. Write an if statement, determine if the median is greater than 70 or not, and then you also gotta finish it off by telling Excel what to do. Here we go. Equals, if, parenthesis. What am I doing? Anybody wanna volunteer? What do I put?
Median.
Median, very good. M-E-D-I-A-N, correct? Is that what we have to do? Median, and then what? Parentheses, what? What's the data from C what to C what?
C7 to.
What is it? Is it really? Is it C7 to?
Can you go up?
Yeah, I gotta scroll up. There it is, right there though. C7 to C31. So hang on, parentheses, C7 dot dot C31, parentheses. If the median C7 to C31, there you go. What do I do next? It's asking
Comma.
greater than 70?
Comma.
Here we go.
Yeah, so you do-
Greater than 70. There's the question. Comma. If it's true, what do I want Excel to do?
Yes.
Say,
You're gonna say
how about
greater
this?
than 70?
Quotation, the median is greater than 70. Quotation, comma. What am I supposed to put if it's false?
Median is not greater
Median is
than
not
70.
greater than 70.
Quotation, the median is not, okay, that's fair, but it could be equal to, so I'm just saying is not greater than 70. Quotation, parenthesis. What I just did is I just answered a quiz question. Everybody get what I just said?
Yeah.
We'll say, hey, write an if statement that determines if the median is greater than 70 or not. Let the result should be stated if it is or is not. Everybody see what the question says? And then this would be your answer, this if statement. There's different ways of writing this, there's different ways, but as long as it meets what's being asked for there.
I was just gonna ask.
Okay, I mean, yes, you may not use those exact words, the median is greater than 70, but something that conveys, letting the person using the simulation that the median is greater than 70 somehow. It may not be the exact words. I want to tell you also, if somebody said median's less than 70, and put this as the median's not not greater than 70, and then have the false be the median is greater than 70, that's acceptable too. That meets what's being asked there. You know, somebody could have used the less than instead of greater than. The point I'm trying to, really you'd have to use less than equals though, to be absolutely correct, because that'd be the opposite of greater than. The point I'm trying to make is though, there's several different ways of answering that question on the quiz, but I'll be looking at what you put and if it will work or not. All right, are we past time? You gotta go? What is it? We have 4 more minutes? The only thing I have left is, okay, I can't remember if I talked about this or not. Hang on. Yeah, turn off the camera so we don't have to edit.